Hi, everyone. My name is Avishai Ish-Shalom. I'm from Tel Aviv, from Israel. Nukenberg on Twitter, if you care about that stuff. I work at Wix.com, which is an awesome company. I'm going to be speaking about Wix a little bit more tomorrow. We have a bunch of people here running around with those shirts that say treasure hunt. Okay? We've got this on our back. Basically, it's a game. You have to scan all 10 of us. 10 shirts, 10 barcodes. You scan everything, you answer the questions, and you get awesome rewards. We have a booth upstairs, so go visit us, come visit us. And of course, we're hiring if you're interested in working with awesome engineers and awesome technology and doing really amazing stuff for a very cool company. Come talk to us after, or me, or whoever you want. You can identify us by the shirts. Very easy. I'm a software fairy at Wix. Yes, this is my official title on LinkedIn. Some people think I'm an engineering manager. I don't know why, but I'm a software fairy, actually. Yes. If you've never heard of Wix, what we do is basically we're a platform for building websites. Currently, we have about 100 million clients, which is pretty much. And we have about 550 developers, maybe a bit more now. Logging is, in fact, not very easy. And unfortunately, it's a very overlooked problem, so to speak. First problem with logging. We know we have fancy logging levels like info and arrow and fatal and all that stuff, but actually in practice, we only have 2 logging levels that exist. They are the only 2 log levels that exist. Too much bullshit, and I'm fucking blind. And there's nothing else. Like, either the stuff you need when you have a problem is in the logs, or it's not in the logs. And if it's in the logs, chances are it's hidden somewhere between 3 million lines of irrelevant shit, right? So those are the 2 log levels that exist, and they're the only ones that exist in practice. Yeah, that's a problem. But if that's not bad enough, you know, logs are very, very hard to use. They're very hard to parse. They have like really weird formats. You would not believe the formats I've seen. Like, I want to take out my eyes sometimes. Like, horrible. Think about dates, for example. You go to log, you see a date, it says 11 of 10, 16. Okay, like is this September, is this October? I'm not exactly sure. Like, is it November or October? I'm not sure. Is it American date, European date? You don't know. Okay? Not to mention time zones. Like, is the log in UTC? Is it in Europe time zone? Is it in maybe the US time zone, one of them? It's like you don't know. And it's like an issue every fucking time, every time. So logs are very, very hard to read, very, very hard to parse. They're very hard to correlate because we have microservices. So a transaction starts on this server, then you have a request that goes to this server and to this server and to this server, and then you have an exception here. Okay? And you need to look at the logs from this server and this server and this server, and somehow find the lines that relate to the same transaction. That's very, very hard. But even if you have one service, finding all the logs that belong to a single transaction from different classes, that by itself is very hard because not always you have a thread ID. Okay? Sometimes maybe it's an executor, so it's a different thread ID. So just correlating that is very, very hard, even in the context of a single server. And if you look at the log, it doesn't have a lot of context, right? You don't know what the parameters of the request were. You don't know what the user ID is. You don't know what the transaction ID. None of that is in the logs. So it's like you look at the log, but it doesn't really help you. It's really, really annoying. And of course, whoever had a server crap out on them because the disk was full because of too many logs? Like, raise your arms. Come on. This happened to me like so many times. It's like at least half the room had this. So I had log4j block on me and killed the performance of my server. I had like so many times that servers died because of disk full, that kind of stuff. It happens all the time. And this is like the one thing you don't want your telemetry system to do, to kill your server. And it happens all the time. And it takes CPU, it takes memory. It's horrible. Now, the thing about logs is, no humans ever read them, right? Whoever went and read 20 gigabytes of log? Did you ever do that? No, nobody sane anyway, reads logs. Like, nobody does this. And we have terabytes on terabytes of logs every day. The fact of the matter is, since the early 21st century, only robots read logs. No humans read them. But do we design logs for robots? No. We design them for humans. This is why we have formats that are supposedly very easy for humans to read, but horrible for robots. So, since anyway we're going to pipe the logs to some log pipeline, like maybe Logstash or FluentD, or one of those tools that I'm hoping everyone is using, tools that basically collect the logs from your servers, parse them, do some analysis on them, filtering and so on, and eventually index them in a system, in a UI where a human can search them. Because that is the only sane way to look at logs. Okay? Since we're all doing that, or should be doing that, we might as well design the logs for robots. Right? That makes sense. So what do we want from a good logging library? We want a logging library to have structured logs so we can write structured data and add context. We want to integrate with the pipeline easily, something like Logstash or FluentD or one of those pipelines. We want to be fast so it doesn't slow down our application. We want it to have graceful degradation, so when we have issues, and normally when do we need the logs? We need the logs when we have issues. So when we have issues, we don't want the logs to crap out our servers. We want everything to gracefully degrade. We want the logs to be able to have context, so we want the ability to add context. And of course, we want event filtering. Why? Because we don't care about most of the logs. We only care about the small subset that actually shows us what the problem was. So on the agenda today, we're going to do a short overview of logging libraries. We're going to talk a little bit about how to add structure and context to our logs. And we're going to talk about separating signal from noise. And finally, we're going to be talking about production-grade logging. So, are we ready? Yay, we're ready! Awesome. Cool. So just before we start, conceptual question. What is a log? Anyone? What is a log? Okay. Can you be a bit more generic? Piece of data and timestamp. Okay, that's cool. I would define a log as a stream of events where an event is a piece of data with a timestamp, or maybe not even have a timestamp, maybe only a sequence number. And it's very important to remember that because actually you can use logging libraries for a lot more than just operational logging. For example, a lot of companies like we do, they have BI events, information about what clients do, and use them for machine learning, use it for statistics, and a lot of other stuff like that. And I've seen people build, really awesome tools to collect this data and process it when all they needed to do is just do log info to a specific logger, and they were done. Okay? So try to remember that logging libraries are actually much more useful. They're very, very useful for stuff that isn't like traditional logging. Okay? A small takeaway. So let's talk about JVM logging. So those are the common libraries that you would find in the JVM world. Java util logging, log4j1, Logback, log4j2, TinyLog, SLF4j, and commons logging. So who's using Java util loggings, by the way? Java util logging, anyone using it? No? Yeah, awesome. Don't use it. Like, it's really bad. It's really simple. It doesn't have a lot of features. It's not particularly fast. It's not particularly good. The only reason to use it is if you don't want dependencies, because it's in the JDK, basically. That's like the only advantage it has, really. So what do everyone use? Of course, log4j1. Now, log4j1, that's a very, very old library. It's mature. It's battle-tested. It's been around for more than 15 years. I don't even remember how long. But the performance is like, and it has a lot of extensions. But like porn, yes, you can find a lot of it. And it's usually free. But the quality is so shitty you want to take your eyes out. So, yeah. Sometimes it's good, but most of the time not. So features. It has features. It has essential features. It has a little extra features, usually most of what you need. But it's not really fancy in any way. And degradation, well, we all like our servers to block, don't we? So yeah, that's the problem. So in Wix, we use Logback. Logback is the second generation of logging libraries. It has pretty good performance, extensions, yeah, well, still point grade. It has many more features. Like, it's a carnival of features. It's really awesome. The graceful degradation behavior of Logback is much, much better. And it's also very mature, very battle-tested. It's a library that's been around for a decade, and it's pretty awesome. And this is why we use it. The new kid on the block, of course, is Log4j2. It's been around for about 5 years, a little bit more. The people who wrote this are the same people who wrote Logback and Log4j1. And a lot of the insights that they gained through the years came into being in Log4j2. So very, very good library. Performance is insane. I have never been able to saturate Log4j2, and believe me, I've tried. Extensions, it's like HBO. Yeah, you still see a lot of nudity and a lot of sex. Quality is a little better, but you don't find as many extensions as you would for Log4j1 because, well, it's been around for less time, so it makes sense. Graceful degradation behavior, very, very good, and of course it has a lot of features. So really awesome library, and if I was writing a new project from scratch these days, I would use Log4j2 and nothing else. So really awesome library. Anybody ever hear of TinyLog? No? Yeah, so this is the logger no one knows about, and it's a shame, because this is an awesome logger. It's fast, it's minimal, it's batshit crazy. Like, the performance is really, really fast, insanely fast, but it doesn't have any extensions. And if you want features, nope, you're not going to get any features. This is a very Spartan logger. Okay, the whole point of TinyLog is to be tiny. Yes, so yeah. If you're doing some kind of embedded development, or you're aiming for small footprint of your application, probably TinyLog is the logger for you. Otherwise, yeah, maybe not a good idea. SLF4j and Commons logging. So a lot of people are using this, and SLF4j and Commons logging are not logging libraries per se. They're actually facades, which basically means that they don't implement the functionality of logging themselves. They just provide interfaces. And you plug in the concrete implementation dynamically when you run your server, during runtime usually. Why would we use that kind of stuff? If you write a library, you don't want to impose your selection of a logging library on whoever uses your library. Okay? So basically, you would use something like SLF4j, and you leave the decision of what logging library to use to whoever uses your library. So if you're writing a library, be friendly, use SLF4j. Why shouldn't you use Commons logging? Anybody use Commons logging? Okay, so if you're considering using Commons logging, go to Stack Overflow and Google for Commons logging class path issues, and you will see why I hate Commons logging, and I don't recommend that you use it. Use SLF4j if you want to live. Or like if you're an alcoholic, use whatever the fuck you want, because nobody cares. Anyway, let's talk about structure and context. So the first mechanism to add structure and context to applications is MDC, known as the Map Diagnostic Context. They kind of renamed that in Log4j2. It's now known as the thread context. Okay? The idea is basically you have a hash map. It's stored as a thread local. So it's the same one throughout the thread. And if you're using a blocking server, it basically means throughout the transaction. So you can set information once at the start of the transaction. Usually, you do this using a filter. If it's a servlet, then it would be a servlet filter or something like that. And you clear it at the end of the transaction, just to make sure that the next transaction doesn't have values from the previous transaction. You can only contain strings because it's a hash map of string to string, but it's very useful to store context like transaction IDs, user IDs, and so on and so on and so on. Unfortunately, because it's thread local, it doesn't get copied to thread pools. So it is very hard to use this with sync frameworks like Akka, Actos, and so on. But if you don't have this problem, then it's awesome. And of course, you can actually do this manually. We have a library inside of Wix that copies our own executor wrapper that copies the thread context, or the MDC, to the executor thread. So that helps. You can also write structured messages. Sometimes you want to have values inside of your message. Think about stuff like time. Maybe you had an operation that took 10 milliseconds and you want to report this somehow. You don't want to report this in a way that is hard to parse. You want to say something like transaction time, 10, right? So it makes sense to have structure for this, to make it easier to parse, so that you can make awesome graphs of the transaction times, maybe a histogram, that kind of stuff. So unfortunately, there's no support for this in Log4j 1 and Logback. Log4j 2 does support it, using two classes, structured data message and map message. You can pretty much infer how they work from the name. But you can fake it in Logback and Log4j 1, usually by convention. Maybe use A equals B, pipe C equals D, and so on. The idea is to make it easy for parsing. Okay? So logs may still need secondary parsing in your pipeline, but if you think about this in advance, it's going to be pretty easy to implement. And we have done this in practice many, many times, and it's really, really awesome. This is how we extract and create a lot of awesome graphs. Now, of course, when you're talking about context, what kind of stuff would you like to have as context for a log event? So first of all, you would like to have identifiers and other extra information like timestamp. Now, it's important sometimes to have both the local timestamp and the standard and the UTC timestamp, because UTC is global. Okay, you don't want to be guessing what was the time zone of the server, but sometimes you still need the local timestamp because of the user context. Users, unfortunately, since we don't have dictatorship, I'm not the dictator of the planet yet, so nobody lives by my time. So unfortunately, when I talk to a user around the planet, he tells me it's 6 o'clock, and it's like not 6 o'clock where I am, so it's a problem. So I need to be aware of the user context, okay? And this is why it's sometimes important to at least log the offset, if not the full timestamp of where this event happened. Also, you want to know which host this happened on. You want to know which container this happened on if you're using container. You want to know which application, because remember, we're in a microservices architecture. And so on, so on, so on. Which transaction was this? Which request? Sometimes you have a transaction that is composed of multiple requests. What was the user ID, and so on. Maybe you have multiple tenants or maybe multiple environments. And of course, if you're doing continuous deployment, you might have several versions of the same application running simultaneously. So it's a good idea to have in the logs the version of the application. So you know that if this was a bug, maybe it happened on version A and not on version B. So some of this needs to be added from your application. For example, transaction ID, request ID. But a lot of this stuff can actually be added after the fact by the log pipeline. For example, host ID. Okay? A lot of the appenders in Logback and Log4j 2 can actually add this automatically if you just configure them to do so. So it's pretty easy. But now that we have all this fancy stuff, we can talk about separating signal from noise. And why is it so important to do this? Because as much as I love metrics, there's usually not enough to debug a problem. And when you have a problem, logs are the primary telemetry channel from production. This is how we get the data that allows us to debug what the problem was. And if you get tons of data, usually you can't really do much with it. And then you're like, OK, so I don't have what I need, so let's turn debug on in production. And what happens then? What happens when you turn debugging in production? Yeah, it slows down, everything breaks down, problems go away because this was a concurrent problem, and now the system is no longer concurrent because it's so slow. The disks fill, so now you have another problem. You get the point. Nobody turns debug on in production. Not in real life. It never happens. Or if you do, well. So it's important to remember that there are two types of logs. Okay? First type of log is statistics telemetry. Think about access logs, for example. Usually when we talk about statistics telemetry, we need 100% of it, or a sizable part of it. Why? Because we use it for business analysis. We use it for capacity planning. We use it for statistics, basically, okay? So we need most of it, if not all of it. But then we have debug telemetry. And debug telemetry is very, very different, because debug telemetry we need only when there is a problem. So ideally, we would have 0 or very close to 0 debug telemetry unless there is a problem. And when we have a problem, we are only interested in the small subset of the debug telemetry that actually tells us what the problem was. We don't care about the rest. But we don't know in advance which subset of the data that is. And therefore, we have to get all of it. And that is not pretty. So we can do better. We can actually get subsets of the data. And we have various mechanisms for filtering that kind of stuff. First mechanism that everyone knows about is log levels. You have trace, debug, info, warn, error. You have fatal and log4j. In practice, no one uses anything except debug, info, warn, and error. Yeah, you have critical and all that stuff. I've never seen people actually use this. Little known fact, you can have custom levels on log4j. I never even thought of a reason to use them. If anybody ever used them, please tell me how and why. You have trace and fatal that are very, very rarely used. The thing about log levels, this is the fastest filtering mechanism there is. The performance implications of log levels are almost negligible, which is really, really good. The problem is everybody abuses log levels, right? For example, this. You go to a log, you see a gazillion errors, and then you go to the programmer and you ask him, what is this error that I see in your logs 1 million times? And it's like, oh, yeah, this one is normal. What? There is no such thing as a normal error, by definition, right? So do me a favor. If you're doing this, at least take this exception and log it as a warning and not an error, so you can actually use this filtering mechanism. If you abuse it like so, like you have shot yourself in the foot because you have disabled the fastest mechanism that you have for filtering events. And that is really, really dumb. You don't want to do that. Second thing that we have is the logger hierarchy. Okay? So the logger hierarchy basically allows us to configure only the top level loggers by package name or maybe just root. And this configuration will proliferate to the rest of the loggers. And it's really, really awesome because it makes configuration very, very simple. Usually, when we set the loggers, we give them names, and the name is usually the class name. But you don't have to do this. You can actually give it every name that you want, as long as it's dots separated, because the hierarchy works with dots. Okay? So think about separating logs, for example, for business logs, operational logs, maybe audit logs, like in this example, and then you can just have a prefix, like audit dot in this case, and then you can configure all the audit logs very easily, because you configure just audit, and it proliferates to all the other audit logs in the system. So very, very easy. And remember that different logs have different requirements. For example, audit log must be synchronous because you cannot lose it. You cannot lose data from an audit log, where an operational log can be asynchronous because it's OK to lose data there. So probably you don't want to configure them the same way. Then we have tags and markers, which is a lesser known mechanism, but it is pretty cool. It's kind of orthogonal to log levels and all of that. So you have a marker, and markers are also they're a hierarchy, they form a hierarchy. So basically, you can inherit a marker and create a modified marker based on that. So in this example, we have an SQL marker. And from that SQL marker, we generate two different markers, SQL update and SQL query. And then in our configuration, we can say something like, I'm only interested in SQL logs. For SQL logs, I want to see debug logs. I don't want to see debug logs for anything else, just for SQL logs, no matter which class they are in. And that is the power of markers, because they're completely agnostic to class names and everything else. But then I decide that I'm not interested in updates. So I can refine this using the hierarchy. And now I can say, I want to see the SQL query logs, and so on, so on, so on. So very, very useful mechanism. Now, if you notice here, logger trace entry and logger trace exit. What is this? Does anybody know this? So this is part of a mechanism known as flow tracing, which is built on top of markers. Okay, so basically it's just sugaring by the logger libraries. And what they did is they have a function that basically logs to the trace log level with a specific marker that is derived from flow, inherited from the flow marker. So you have functions for entering, for exiting, for catching, or for throwing errors. And basically it makes a trace log of everything that happened inside your function. So what you would see, basically, is you would see a log line that says, entered function example exception with argument blah, blah, blah. And then when you exit the function, you will see exiting function example exception at this time with the return value of whatever. And it's pretty useful when you need a tracing mechanism. Often you would not have a tracing mechanism that you can connect in production, and this is a very easy solution that you can implement in your code. It does require code modifications, although you could just use AOP or something ugly like that to do this without code changes, if you want. It's doable. But it's probably not a good idea to put this in the critical path of your application or on performance-sensitive code, okay? Because it still has some overhead, although the JIT does optimize most of it. But of course, we want a subset of the logs, okay? And often when we have a problem, we don't have one exception. We have maybe 1,000 exceptions every minute or every second because, if something is broken, it's probably broken for a lot of people. And we don't need the debug logs for all the exceptions, for all the problems. We need the debug log for a sample of them. Even one would be enough in many cases. So how do we extract just a subset of the logs? So one way would be to put in a thread context or an MDC a number, maybe a random number from 1 to 100, and then filter on that number in the configuration of your logger. So this is a configuration from log4j2, and basically it configures the appender to only log stuff that has as a user fraction the value 1. And because we use a random value, this means that only 1% of the logs will be emitted, which is really awesome because, frankly, I only need this fraction. The nice thing about this, that this changes the logging level for the entire thread. Okay, so I will have the entire transaction logged, and not just an arbitrary fraction of logs like you would have if you tried to do this in a pipeline. But, of course, sometimes we're interested in specific users or a specific transaction and not a random fraction. So what we would do instead is we would put in the thread context maybe the user ID or, let's say, a Boolean value. Let's call it trace, which you can set as a query parameter. And in a microservices architecture, you might want to think of passing that from service to service in your protocol. So you can set trace equals true in your query, and suddenly all of your microservices emit debug logs for this transaction, which is really awesome. And this is basically how you do this with log4j2. You have a dynamic threshold filter, and it changes dynamically the log level based on the value of that specific key. In this case, maybe a user ID, because I want to see the debug log of this one customer that is complaining that he has issues. Okay? So pretty cool. Another mechanism that is very, very useful when you cannot change the configuration of your logger dynamically is something called retroactive logging. Basically, the idea is we write all the debug logs, instead of directly to the logger, we write them to a ring buffer or a circular buffer. And we keep them in memory until the transaction ends. When the transaction ends, we know if we had a problem or not. And if we had a problem, we write everything to the logger, and then we have the debug logs. But if we didn't have a problem, we know that we don't need the debug logs for this transaction. They're not interesting, and we can just throw them away. And then we would have the debug logs only for the problems. And this is really awesome. This tactic is very popular on embedded devices and disconnected environments where you cannot change the configuration of the loggers. Unfortunately, there is no library to do this, but it is pretty easy to do this yourself, so highly recommend it if you need this. Now let's talk about production-grade logging. First thing that you need to know about in production-grade logging, is that even in presentations, everything fails in production. Awesome. First thing you need to do when you're talking about production-grade logging is log rotation. A disk log is basically a buffer. And like all buffers, it should have a preset size. Okay? If you're using time-based disk log rotation, stop. Use sized base rotations. Okay? Just say I'm willing to buffer 2 gigabytes of log and no more. And that's it. You will never have another problem with the disk filling up due to logs. It's that simple. Second thing is, you might want to use a separate partition for logging so you don't fill the system drive and kill the operating system. You will just be killing your application, and that's fine. It's better. Second thing is, use serialized logs, like JSON or protobuf or message pack or thrift or whatever format you want, JSON. A lot of those formats are binary, and that is fine. Serializers are fast. They're much faster than string formatting, which was awesome. And remember, who's going to read the logs? Robots. And robots, they like serialization. They don't like string processing, do they? Most people, the way they handle the pipelines is they have horrible, horrible regular expressions. Like, you would not believe how horrible those regular expressions are. They burn a lot of CPU to parse the logs. And then we get to this really weird situation where we have one machine that is spending a lot of CPU on generating strings, and then we have another machine that is spending a lot of CPU on parsing strings. Does this make sense to anyone? No, it doesn't make sense. Just use serializers. A log event is basically a Java class. It's a Java object. So just serialize it, and that's it. A lot easier this way. Also, it preserves structured data, so you don't need to parse it in weird ways, and you don't get a lot of parsing errors, which is also awesome. Next thing is async appenders. This is very important. First of all, you get a huge performance boost from using async appenders. They're much faster than synchronous appenders in most cases. Second thing is they are fault tolerant, and they allow you to have graceful degradation for your logging subsystem. The only thing you need to remember, not the only, but the most important thing you need to remember when you use async appenders is to properly shut down the logging subsystem, because it has to flush whatever remained in the queue of the async appender. Otherwise, you might lose logs. Okay? So very important to remember, but it's pretty easy. It's just a register shutdown hook or something like that. Whoa. So, handling load with a sync appender. Basically, an async appender is a wrapper around another appender. Okay? It has a queue. You put the events in the queue, and then you have another thread consuming the events from the queue and writing them to the wrapped appender. Okay? In Logback, the async appender does a very neat trick for the graceful degradation. It measures the size of the queue, and if the queue is filling up, more than 80% full, it starts dropping low priority messages, like debug, trace, and so on. And you are only left, you're only still logging the important messages, warn, error, critical, that kind of stuff, which is really awesome. Because if you have a problem, you don't want the logger to completely block and stop emitting messages. You want to have at least the error messages that tell you that something is wrong. Okay? Log4j 2 does something differently, but also very good. It fails over to a secondary appender. Okay? So think about a network appender and a disk appender. Usually you would write your logs to the network, but if there is a problem and the network is down, instead of blocking or losing logs, you would write to the secondary appender. You would write the logs to disk. Okay? So again, very nice graceful degradation behavior. Log4j also has something very cool called, it's basically throttling for events. It's called a burst filter. And basically, you set preset rate for your events. You can also have a different rate for bursts. And it protects you against excessive logging. You don't want to get, let's say, more than 1,000 logs a second or whatever. So you put this in place. You wrap this around another appender. You can see here the appender ref. This is the wrapped appender. And basically throttles your logs. Okay? And it drops the events when you go over the preset rate. So very, very nice and helps you a lot. Who's doing this? Practically everyone. Come on, let's be honest. Who's not doing this? What's the problem with this? First of all, yes, there's no need to check if debug is enabled. The logger knows this. But why are we doing this? Yeah, we don't want to evaluate the object. We don't want to convert it to string. But this is a very bad way of doing this, right? First of all, it looks ugly. And in Java, this means that you have to put this stupid snippet everywhere. It hurts readability. And also, this is optimized for the good case where you don't actually have debug enabled. But what happens when you do have debug enabled? You have 2 function calls instead of 1. So actually, just when performance becomes shittier, you have made it worse. So probably not a very good idea. There is a better way. All the loggers support something like this, which is basically they do their own formatting for you. And you can submit object, just a reference to the object actually, as an argument, and they will check for debug, for is debug enabled internally, because this is what logger debug does anyway. And if debug is enabled, only then will they try to convert object to string. And in Java 8, you have even a nicer trick where you can just give it a lambda. And this lambda will be lazily evaluated if debug is enabled. Okay? So a lot easier, looks a lot nicer, and you don't have to worry about anything. The logger does this for you. Last thing we're going to be talking about. A lot of the tactics that we have, that we've discussed, depend on the ability to reconfigure the logger at runtime, right? There's no point showing you all those fancy filtering mechanisms if you have to restart all of your servers, in order to change the logging configuration, right? So lucky for us, all of the loggers nowadays support runtime reconfiguration. Logback and Log4j2 actually support watching the config files and automatically reloading the config file if you change them. All you need to do is set something in the config file. In Logback, it's like a file scan interval, something like that. Pretty easy, and that's all you need to do. Also, Log4j2 supports JMX. So you can actually connect with JConsole or JMXterm or whatever JMX tool you like to use, and just load a different configuration without restarting the server. And of course, all of the loggers support programmatic configuration, so you can build your own API for reconfiguring the logs on top of them without a problem. At Wix, we have something like this. We have a console where you can put in the package name and change the log level for a certain amount of time dynamically. Okay? So pretty easy and highly recommended. So we are at the end of our talk, and if you have any questions, now would be a good time. Yeah, any questions? Over there.
Hi, thank you for your talk. So I have a question about log rotations. On my current project, we use Logback, and there is a really strange issue with this because max value of all logs in your machine is integer value. So if you want to store about 4 gigabytes of log, there is integer overflow and you have issues. So we solved it just decreasing up to 2 gigabytes. But is there such issue with Log4j2? Yeah, and maybe you meet such issues.
I didn't have this issue with Log4j2, but to be honest, usually what I do is I keep several buffers, so let's say 500 megabytes for each file, and I keep like 4 of them, and that's usually enough for me. And usually the pipeline by that time should have already copied the data somewhere else. So that's usually enough for me, and I've never had problems with this, to be honest.
Yeah, but sometimes if you need to rotate each day, some files cannot be about
This is why I don't rotate each day. The problem is that you don't.
Okay.
The problem with the time-based rotation, and when you say something about rotation each day, I'm assuming this is what you mean, is that you don't know in advance what the rate of logging would be. Often, when you have a problem in production, the logging rate goes up by a factor of 10. Okay?
Yeah.
Usually, you don't have exceptions. Now you have a lot of exceptions. And then the same space that would suffice for a day doesn't even last you an hour. So this is why I don't use time-based rotation.
Okay, thank you.
You mentioned structured data messages and
yes.
map messages.
Yes.
What will they look like in the log file?
Oh yeah, I should have shown an example. So in Log4j2, they would look. Log4j2 converts them automatically to pairs with the equal value. So if you write A B in the map, you would get A equals B in the log.
So it's not some specific structure like JSON. It's just key
it's
values.
It's not JSON structure. It's a key value structure, which is still easy to parse, but unfortunately can't use a deserializer.
Okay, thank you. And
by the way, one neat trick that you might be interested in, Log4j1 and I think also Logback supports logging objects directly instead of strings. And then you have something called an object renderer that you register in the logger, and then you can do the conversion whatever way you want, for example, JSON. And we have used this to generate access logs from Jetty and Tomcat in a native form. We just took the request object and the response object, we logged them as is, and we serialized them.
So it's some kind of custom serializer, yes?
More or less. It's actually easier than a custom serializer, but yeah.
Okay, thank you. And one more question regarding log marks. You said that they were useful, but I didn't get an idea what's the benefits of using marks.
Log markers are orthogonal to log levels and packages. So if you have a concern that is different from what you would know, that may be scattered around several classes. So think about DAO, for example. So you have SQL. In a DAO, you have data conversions, you have data parsing, and so on. And not necessarily you need logs for all of them when you have a problem. Maybe you suspect the problem is in the SQL queries. So if you set debug log level for the entire DAO package, you would get the SQL logs with the conversion logs and everything else. But you are only interested in the SQL logs. So if you set markers for the SQL logs, then you can say, regardless of the package, I only want the SQL logs.
So it's a way to configure a login level more precisely and not based on packages.
Messages, yes.
Okay, thank you.
Hi. Do you know any, what can you advise about search data into the logs? Like if I need to search some object with the field foo equal bar and something like that. And maybe you know some tricks to search during the SSH console instead of just lessing it or tailing and just usual algorithms.
Okay, so the question was, how do you search the logs? I prefer not to read the logs on servers because, first of all, we have a lot of servers. You don't know where your application lives. Just finding the server and SSHing into it takes time. And even if you did, not necessarily the transaction would be on that server. You want to know what happens overall in the system, not on a single server. So when you have clusters, you have to use some other mechanism. SSH is not good enough. What we do basically is we stream the logs using the pipeline, log/, in our case, FluentD, and we parse them and we index them in Elasticsearch. So there's the elk stack, which is very nice, and then you have Kibana, which is a UI that sits on top of Elasticsearch, and then you can have histograms, graphs, whatever. It has native search, very easy to search. Highly recommend that you use this. And the only thing that you need to know is that probably you want to configure some kind of schema or a loose schema for this, and log all the fields that you're interested in. But if you want to hear more about this, come talk to me after. Awesome. So we've run out of time for questions. So if you're interested in talking to me more, I'm going to be outside. So also you can catch me at the booth, and remember the treasure hunt. So yes, I will show you later. So thank you very much.